graph radicals for the next 3 days. So today, tomorrow, Monday. All of those days you have worksheets with graphs on them. So in your notes, you can just sketch it. Don't stress about it being perfect. But when you get to the homework, it'll be nice. Okay. I'm recording. So today and tomorrow we're going to do, so remember, radical is just this symbol. And then you can put a square, a cube, fourth, as you guys know. Okay. So we're going to do square roots, like I said, today and tomorrow. And then Monday we'll just do the cube root. So here's the parent function. And from here on out, I usually just put PF, okay? So parent function, it's the most basic form of the graph. And that would be that, y equals the square root of x. And to graph these, we make a table of values. Now, let's see, someone who had a really high grade. Sam, what were the values for x we always picked? Right, -2 to 2. And we talked about, thank you, we talked about why we picked those values. Simply because it's easy, right? They're right in the middle of the graph. We have numbers to the right and to the left of 0. But we're not going to pick any what numbers. Fill in the blank. What are we not going to pick to put in there? A whole group of numbers. Negative. Right. You can't have a negative number on a radical unless you're going to go into imaginary numbers. Let's not bring back those nightmares right now. But so we only want positive numbers. And really, any positive number, including 0, is totally fine. If you can do it on your calculator, the number is fine. So the square root of 0 is 0, okay? Another good number would be 1, right? If I plug a 1 in here, the square root of 1 is 1. Now, I can do the square root of 2. I can do the square root of 3. And those are numbers, right? Are they very fun to graph? No, they're decimals. So what would be the next number? Common sense, I mean, not like that. What's the next obvious, I hope, number that we would use for x value? 4. The square root of 4 is 2. And that's as many numbers as we need. Really, the 3 points for these is going to be perfectly fine. So that's for the parent function. But you guys know that not every problem is going to be that. That's one example, right? There's going to be other numbers thrown in there. And that's when we transform the graph. Transform the graph. Okay? And we've seen this before. I'm going to add some letters to the parent function. So y equals an a in front, x minus h under the radical, plus k out to the right. A, h, and k. Even if you don't remember exactly what they are used for, I'm hoping at least they sound familiar. Okay? We're going to deal with A tomorrow. We're not going to do anything with A, but an A, tomorrow we'll talk about it, is a stretch or shrink of a graph. Does anybody remember what H does to your graph? It moves it a certain direction. It's left or right. Left or right, and it's opposite whatever the sign is. So if you have a positive H, we move left. A negative H, we move right. So we've done this before with parabolas where it's in the parentheses, and so the number in the parentheses is always opposite. It moved your graph left or right, but if you saw a positive number, you moved it to the right. A negative number moved it to the left. So K would be what direction? Up and down, right? Up and down. And it's not opposite. Positive K, we go up. Negative K, we go down. So if I were a smart, good student, I would be making sure I have this in my notes so I can look back at it until I have it memorized again. Okay? So again, today we're just doing H and K. We'll add A in tomorrow. Okay? So here's the steps. These are what you're going to do. Okay? So the first step is going to graph the parent function using x's. And I'll explain what that means in a second. Okay? And I'm going to write don't connect. This will make more sense when we get to our first, that'll make more sense when we get to our first example. Brian, you writing? Robbie, you writing? I can't see. You taking notes? You get these A's. I can't imagine, Brian, what you could do with that brain. You really, he gets A's on everything, and he just watches me. He's watching. Okay, and the last thing you'll do is translate. Translate just moves. Translate or move the parent function points according to H and K. It's very, very simple, okay? But it's going to be very helpful to have this in front of you in case you're like, wait, which way do I go, or what do I do? Because tomorrow we do all of this with one extra thing done to it, okay? Are you able to text without even looking down at your phone? Amazing. I used to watch students do this with their phones. Like, they'd have their phone under their desk, and I could see their fingers doing this. And I'd be like, are you texting? Like, you guys are amazing with your texting, how you can do it. I just watched Seymour. He was like this. Nate was like this. He's looking at my screen, but his fingers are moving. He's not even looking at it. And I said, are you texting without even looking at your phone? He's like, yeah. I believe you. I believe that you are. Okay. Wait, what? Why are they talking about a basketball game in the middle of this exciting lesson? What? How did that even pop up? We're talking about transforming radical functions, and you're like, 2 points. Basketball game not over. Okay, ready? Ready? Okay. So, no. Look how small the space is. Nice and easy. Guys, if it helps you to have that parent function points, because you're going to graph these over and over, you should have them memorized by the end of the notes. You start with those parent function points each time. Remember those points we came up with here. These are your parent function points. That's where we start. Remember I said step 1 was graph the parent function using X's and don't connect. Okay, let's just, and you guys might not be using graph paper, totally fine. You're just going to sketch a graph for now. I'll give you graph paper. So we always start out by graphing these points using X's. 0, 0, 1, 1, 4, 2. Okay? And don't connect them. I wouldn't take points off if you connected them, but trust me, it just makes the graph really messy when you do your final graph. So that's my parent function, and I used X's. So that's not my final answer. All I did was graph that, right? F of X equals the square root of X. But what am I going to do to all of those points when I have a +3 under the radical? What direction is that going to move all my points? Left 3. Left 3. Again, go back to your H and K. Remember, if the number in here is positive, it's to the left. So until you have this memorized again, use your notes. So left 3. So look, guys, if you blink, you'll miss it. I'm literally moving each point to the left 3. And I know you're not on graph paper, so just estimate right now. I'm sure you can understand the concept. I'm using different colors and all that in real graph paper, but the reason I have you do X's and then plain dots is that you know which ones to connect once you're done. So your parent function guides your final function. That's it. Doesn't get much easier than that. Let's do this B example. Sketch yourself a graph. Always start with 0, 0, 1, 1, 4, 2. Always. Make X's, leave them. Then look at your given function. This +3, notice it's not under the radical. It's all the way to the right. That's your vertical movement, or up or down. What direction is +3 going to take us? What? Well, that was left. How could these be the same? This one's under the radical, this one's not. Look at your notes. If a number is all the way to the right, see how I pushed it? I did it on purpose, like I made it really far away. It's not under the radical. That's your up or down. And that's not opposite. Positive goes up, negative goes down. Do you see that, Shane? Yeah? So I'm just going to take each of my points and go 1, 2, 3. 1, 2, 3, up. 1, 2, 3. 1, 2, 3. 1, 2, 3. And notice it's only got arrows on one end. Okay? We didn't put any points to the left of our first point, so there's only one arrow in these graphs. If you put 2 arrows, like on the other end, it's wrong. We don't have points over there. Okay? Let's try 2 more. Again, every single time, you're going to get bored of it, but good, because it's easy. 0, 0, 1, 1, 4, 2. We start there. Parent function done. What direction is this minus 1 under the radical going to take us? 1 to the right. Okay? Guys, the graphing of this is so simple that it's hard to mess it up. The only thing that we could really mess up with these is not knowing what direction the numbers go. So when it comes time for the homework, that's very short. You do not have a lot to do. You will all finish with time left over. Try not to just copy my answers. Don't just copy it because you're not learning anything. Try it, look up, and make sure you're going in the right direction. Okay? Really, that's how you're going to learn how to do this. So again, I'm just going to take each of these points, write 1. And you can see in an example like this how helpful it is to have X's and dots. So it's very clear to me that I'm going to be connecting the dots. Could I accidentally touch or go through one of those points? Of course. All right, that's totally fine. It doesn't mean you can't cross into them or anything. But that be it. And last one. Zero, 0, 1, 1, 4, 2. What direction does this minus 1 take all of our points? Not down. Not under the radical. So that's up or down, and it's not opposite either. Minus is down. So count down 1, connect those dots, arrow on the end. Easy peasy, right? No big deal. Now listen, I'm going to give you guys a worksheet that's for today and tomorrow. Okay, so don't lose it. And you'll notice at the beginning of the notes, I wrote the odds. You're doing just the odds. Just the odds. The evens are for tomorrow. And I even wrote that up here. Today, day 1, we're doing the odds. Tomorrow, the evens. Okay? So don't do the evens. You haven't learned how to do them yet. Okay? Leave here today feeling super confident about this. I'd be happy to help you go over anything. Okay, just the odds, just the odds, just the odds, just the odds. Let me find it. Oh, sorry. I'm sorry. Oh, I did this. I'm just saying I didn't forget, which is important to me for some reason. So let me put this on Canvas too, so it's fun for you guys to see. A little hard to see. Odds only today. Tomorrow we're doing the even. Don't lose this paper. Let me put it on canvas real quick so you guys can see it. Why? How many copies do you think I make? Here, come get it done. Why not doing this work? Yes. Did you guys give me my pen back yesterday?
I did.
Evan, did you give me back my pen yesterday? I don't normally let people use them. They spent it. Yeah. Even if you go right one down two. Yeah, I should have put one on the notes that was a combination. Yeah, you can do more than one. Just go right or left, then up or down. So you can do simple. It's up four. Yeah, sorry, that was a U. Sorry, that was a U. I gotta read. Thank you for catching that. It was like really faded, so I went over the letters. But